So let's look at another question and see if we can apply this idea of geometric mean in order to solve for unknown values in these similar right triangles again. So here we have, again, our three different triangles kind of nested into one. So we have, this big triangle here, the little triangle here, and then, our other little triangle here. And as always, our first step is always going to be to label these points. So I'm going to call, that's a highlighter. I'm going to call this one A, this one B, this part C, and this one D. So now remember, if we go back to the rule that we were talking about before, the altitude is the geometric mean between the two pieces of the larger triangle's hypotenuse. So we first want to look for two key pieces. Where is the larger triangle's hypotenuse? Remembering again that the larger triangle is this triangle ACB here, and the altitude is the piece that is separating the larger triangle into two tiny pieces. So in that case, the altitude is going to be this dB here. Try and make it kind of dark so you can see. So the hypotenuse that the altitude is separating is this segment right here, that AC value. And so the altitude is separating the larger triangle's hypotenuse into the pieces D and C. So what is the value of the altitude? Well, the altitude we see is labeled as x. So we know that x is the geometric mean between 6 and 3. So if we use that idea, we can say, 6 over x is equal to x over 3. Now we can cross multiply to solve for x, and we have 18 is equal to x squared. Take the square root, and the square root of 18 is equal to x. And again, you'd want to make sure that you would simplify this radical expression, but again, I'm not going to do that for time here in this case. So now you might be saying, okay, we've done a few instances to solve for one of the variables, but what about my y in this case? Like, what do I do once I have this x value? You're like, how do I set up a proportion for the y? Well, I would actually argue that you don't have to. Instead, what you could do, rather than trying to work out all the difficulties and intricacies of setting up those proportions, is you instead use your Pythagorean theorem. So look, for instance, where you see that y being used. You can see in this instance, we have our y present in this triangle right here. And because this is a right triangle, we know that a squared plus b squared is equal to c squared, where c squared is the hypotenuse. Now the hypotenuse, again, is a side opposite that right angle. So here, the right angle is here in that triangle. So the hypotenuse for that pink highlighted triangle is y squared. So we know that y squared is equal to, what are its other side lengths? X and 6. So we can say that 6 squared plus the square root of 18, because we solved that for x squared, is going to be equal to y squared. And then we could solve this equation rather than set up a complicated ratio in order to figure out what the value of y is. So 6 squared is 36. The square root of 18 squared is going to be 18. And y squared is y squared. So 36 plus 18, it's 14. 54. So we have 54 is equal to y squared. Take the square root. Y is equal to the square root of 54. And just like that, you've solved